Second presentation of the first tutorial about application of machine learning in assessment of our system assets. Now, the second part is description of the data set that I will be working with. Okay, so we have, in this example, or the coming two examples, when we'll do some hands-on tutorials, we will use a data from a transformer, from transformer testing. So we want to describe this data, but as I mentioned before, I will not assume that you have any background about the subject. So assume that you don't know much about transformers. Okay, so I want to explain in a very simple language what is this data, and because it is related to transformers, so I will talk about it a little bit. So if you don't have any background about it, you can have the necessary background to understand the coming two examples. So basically, transformers is a very important part of the power system. We connect them when we generate the power, and the reason why, because they step up the voltage. So we need the transformer to step up the voltage. Usually we generate the voltage from the generators or the power from the generators at around, let's say, 13.8 kilovolt. Okay, this is a medium voltage. We cannot transmit the power at this voltage for long distance because the current will be high, the losses will be huge, and we will lost most of the power. So what we need to do, we need to increase the voltage level so that the current will be reduced, and hence the losses will be small. So we need to connect the transformers at the generation stage. Then we transmit the power for long distances until we start to come closer and closer to the city. Then we need to do the opposite. We need to step down the voltage. Why to step down the voltage? Because we cannot utilize the power at very, very high voltage. So we have to step it down until it reaches to the 120, 240 voltages, 220 volt, depends on the country standard. You will step down the voltage to a very, very small value. Now, these transformers, as you can see, these tanks, depends on the power rating of the transformer, could be huge, very large, or it could be moderate, or it could be smaller. They are filled with oil. And this oil has two main functions. It's used for cooling because you have power, current flows, current heats the conductors, so you need to dissipate this heat. Dissipating this heat, we use the oil. The second, because of the high voltage inside, you need to electrically insulate the high voltage of the conductors from the grounded tanks. Okay, and one of the insulating medium we use is the transformer oil. Now, with time, transformer oil tends to what? Tends to age and start to lose its properties. So this is two examples of new oil, how it look, very nice, very bright, and this is very old oil, so you have it becomes very, very dark. So there are certain parameters we use to quantify this aging of the transformers, and the data set that we'll be dealing with in the coming examples is related to the transformer oil test data. Okay, so a little bit of the data set description. This is a data set of 730 different oil-filled transformers. Okay, these transformers are rated between 12.5 to 40 MVA transformer. This is the power rating, and all of them, they change the voltage from 66 to 11 kilovolt, and it is coming, all of them, from one specific country. Now, this is a sample of the test results that we have. So this is the sample number 1 to 7. We have 730 of those. Now, we have the water content in ppm. These are typical numbers. We have the acidity, and these are typical numbers. PDV, or breakdown voltage, these are the numbers. Dissipation factor, color, and interfacial tension, or IFT. Now here I want to stress about something very important. The machine learning should be able to help you with a practical problem. So it's very important before you start jump in the machine learning to understand the physics of the problem so that you will see, okay, is there any correlation to the problem I am trying? Is there could be a relation between these parameters so that I can predict one or some of them? So understanding the physics of your problem is of extreme importance. Otherwise, if you don't understand the physics, you will not be able to understand the meaning of the results. And many times you've seen that results doesn't make any sense. Okay, I remember one time I was reviewing a paper, and the authors are measuring currents in microamps, and they are doing all these fancy classification. But the microamp is basically noise. It was not actual or capacitive current. It has nothing to do with the insulator. Okay, but because they don't understand the basic physics of this leakage current on the surface of the insulator, they write, I mean, the nice fancy neural network and use all these big words of machine learning, but they lack the basics of the physics of the problem. So whatever they do, it has no value. So I stress on this. It's very important to understand the physics. And as I mentioned in the first lecture, I assume you have no background on those, so I will give you a little bit of background. So we have the water content. This is the standard and ASTM. There are both an ASTM and IEC standard. I don't need to go in details. So the water might be present in a dissolved or in a free in the transformer oil. And the presence of oil is bad. It's not good. When you have oil, sorry, when you have water in the oil, this is something is bad and it's not good. Now we cannot detect that visually. There is a special test. I don't need to go through this, but the water will be usually in particle per million. So it's a very small quantity. So the higher the water, the bad is your oil. The second is the acidity. Now here it is a reflection about the acidic components of the material. Now you have high voltage, you have oil, and you have insulation papers. Okay, you have some arcing inside, so there could be some chemical reaction that will lead to some acidity inside detected in the oil. Now in a new oil, any acid present is because of some residual from the refinery process. I mean, those oil, they are coming from the crude oil. So the transformer oil is coming from the crude oil. Sometimes there are a little bit of traces. However, in surface, as I said, this acidity is a measure of the acidic byproducts of the oxidation of the oil. So whenever there is some oxidation, then the acidity goes high. So higher level of acidity is bad. It's not good. Then we have the breakdown voltage. This is a standard test done by many utilities. It basically, I will explain in the coming slide how it's done, but it is a measure of how good the oil to withstand the voltage. We mentioned that transformer oil is for thermal dissipation, okay, and or heat dissipation, and to insulate, electrically insulate. Insulate what? High voltage from ground. So you have to have a strong breakdown voltage of the oil. So if the oil has some contamination, then the breakdown will go down. So here, breakdown voltage higher is better. Lower, as the breakdown voltage start to go lower and lower, it means that the oil is not good. Another important thing here, and as I said here, understanding the physics of the problem, a high BDV or breakdown voltage does not always indicate that there is no contamination. Because I have seen oil that has a lot of contamination, even from their color, but they have still breakdown voltage. What does this mean? It means that breakdown voltage is one of the least sensitive tests that can measure a change of the aging of the transformer oil. How we do it? It's very simple. We have this test is done automatic. So we have this compartment, small compartment. Here there is 2 electrode. These 2 electrode, they have 2.5 millimeter gap, and we apply a voltage at 2 kilovolt per second. Increase the voltage until a breakdown happened. When a breakdown happened, the voltage stops. There is some sort of mixing of the oil to remove the hydrocarbon, the carbon materials, and then apply the voltage again. You do that 6 times, and you take the average value of these 6 times. This will be your breakdown voltage of your oil. Then we have what we call the dissipation factor. Now, the ideal oil is pure capacitance. So if you apply an AC, there will be no heating part or no resistive component. But as the oil start to get contaminated, then you will start, the oil will start to convert from an ideal capacitor to a capacitor with parallel of a resistance. So we can model the insulation as an R and as an C. Okay. Now the dissipation factor measures this R. Okay. So the higher the dissipation factor, the bad is the oil. Color is something visually you can inspect it. There is a scale. You look to the oil. Good oil, you have a bright light color, and old oil or aged oil, you will have a very dark color. The last one is the interfacial tension. This measurement it measures the surface tension of the transformer oil against water. Now, this is very sensitive test. Even for a very little amount of polar material or polar contamination, this will result in reduction of the interfacial tension. Now, compared to all the previous tests, this is the most expensive test, and it needs special people to do it. Not anyone can do it. You don't see it in too many labs. While I was working at my transformer company, when I was, this is a long time ago, we used to do breakdown voltage, we used to do the color, we used to do the water content, but the interfacial tension, especially this one, we used to send it to a lab to conduct it for us. These are some values from the standard. For example, breakdown 26 is the accepted value. Below this, considered as a bad oil. Higher than this is acceptable oil. Interfacial tension, this is 24. This is the minimum value. Because for the interfacial tension, you want the value to be high. Mean that you need more tension, more force to separate the water from the liquid, so that it means that they are not homogeneous, or there is no polar contamination inside the oil. Water content, maximum 35 ppm. So as we said, we don't want to have water there. Acidity 0.3, again maximum. We don't have to have acidity. Now, once we understand the tests, let's come to the problem formulation. What do we want to do? The objective here, we want to reduce these tests. These tests are done at a regular basis. So we were thinking, okay, let's predict some of those tests, because as you can see in all these tests, they are related to contamination, they are related to aging. So maybe I can predict some of the tests using existing tests, and this will save a lot of money for my utility. I don't need to do all these tests if I can accurately predict certain tests. And I selected here to predict the IFT, the interfacial tension. Why? Because as I mentioned, this is the most expensive test. So it makes sense to come and try to predict this value. So in the coming two presentations, I will try to predict the IFT using a regression problem, so to predict its value. And then we'll see how we can make this regression problem a classification problem, which can be applied to many of the regression problems. And I will also try to predict its value. Thank you for joining me for this tutorial, and we will meet in the coming two ones. The coming two tutorials will be mainly hands-on. I will have the data, I will have the software, and we will be working on them. Thank you again, and see you soon.